Hello, we are going to be doing some accelerated motion problems. I pulled some problems from a couple of our quizzes that we had, one of practice quiz on accelerated motion, which is still open that you can take, and the other CoLab quiz on free fall that we took. And I just pulled 9 problems total out of these quizzes just to show some of the setup and the equation and what you could do mathematically to get to an answer. Most students really have not a lot of problems with setting up the variables and picking the right equation. It tends to fall on doing the math that's an issue. For that, you just got to practice it. So we'll do some of the calculations and stuff here together, but for the most part I want to focus on the setup and then selecting the equation. So for the first question, it says a bicycle initially moving at 4 meters per second begins accelerating at 1.7 meters per second squared. After 33 seconds, how far will the bike travel? So these are just kind of randomly pulled questions. They're not going from easy to hard. But what I recommend is, as you're reading the problem, you should always have a list of the variables ready to go. But it's not a bad idea to go ahead and start labeling things next to the numbers. So a bicycle initially moving at 4, you might say, well, pretty sure that's going to be v0. So you can write that next to it. Accelerating at 1.7, that'd be your A. 33 seconds, that'd be your T. And then it's asking how far, you can write delta x. It's not a bad practice. But we do want to have a list of variables so that way we can very quickly see what it is that we're missing and select the correct equation. So in this case, I would have a question mark for my delta x, 33 seconds, original velocity 4, and acceleration 1.7. In this case, we're looking for an equation that has displacement, but it does not include the final velocity. So taking a look at the flow charts, we'll pull that up here. If we needed or were given displacement, we'd want to operate within these two equations right here. And in this case, we'd want the 1/2 at squared equation. So let's go and write that out. We got delta x equals v0 times t plus 1/2 times a times t squared. And at this point, we can substitute in the numbers that we know. It's always a good idea to do a double check, though, that you only have one unknown. So I've got delta x is my unknown. I know v0, I know t, I know a. Everything else is good to go. So at this point, you're 2/3 of the problem in. The rest is going to be substitute and solve. So delta x, I've got 4, 33, and again, note that I'm putting in parentheses around all the values that I substitute in. There seems to be an issue when people are working out problems that they will accidentally start adding or subtracting things. And I think it's just because when things are in parentheses, you tend to think things in parentheses are multiplied together. But when you leave the parentheses off, sometimes that plus sign there looks like it's operating between the 33 and the 1/2, and you make little mistakes. Let's go ahead and calculate this one out. Times 1.7 times 33 squared. I think we should get a pretty big number for this one. Yeah, 1057.65. So let's take a look at number 2. And for these, what I'm going to do is ask you, you should go ahead and try to work out the setup for this. Pause the video, take a look at it, try the problem out yourself, and then watch my kind of walkthrough. It's going to be a little quicker for the rest of these because we've already gone through the procedure once. Don't want to spend too much time on it. All right, so truck starts from rest. That's going to be an initial velocity of 0. It gets to a velocity of 45, and the time is 4.5 seconds. They want us to calculate the displacement of the truck. So if I go back to the old flow chart here, oops, I can get to it, there we go. For the flow chart, we'd want an equation that's final velocity, not acceleration. Maybe that's not going to be the best choice, flipping through the stuff like that. So we don't know what the acceleration is. We can write a slash through it. So we use delta x equals 1/2 t v plus v0. If I plug in the numbers, Okay, my penmanship's pretty bad there. If I calculate that out, I get 101.25. All right, let's take a look at the next problem here. It says dog moving at, by the way, pause it, try it yourself. When you think you're ready, go ahead and unpause, we'll see my solution. And go. So dog moving at 2.9 meters per second accelerates. So it's accelerating after it was already moving at 2.9. So that means the final velocity is going to be 5.3, while accelerating has a displacement of 37. And we want to know how much time it takes. So we're looking for the t. And it looks like we're going to use the same equation that we had up above because we have no acceleration. So delta x equals 1/2 t v plus v0. T's are unknown. I'm sorry, I forgot to write in the delta x there. And in this case, I'll go ahead and show the algebraic steps because where some people make mistakes. We're trying to solve for t, so we want to isolate it. Can't do anything with the 37. The 1/2, not going to mess with it just yet. But the 5.3 and the 2.9 we can add together, so we get 7, 8.2. Now we can go ahead and multiply the 1/2 and the 8.2 together. We get 4.1, and at this point we can divide to figure out what the time is. Should be whatever 37 over 4.1 is. And I get 9.02, which we'll just call 9. It doesn't really matter for that small of a decimal. Oops, I put a t there instead of an s. Losing my brain. 9 seconds. There we go. All right, question number 4. Last one from the just standard accelerated motion problems. Again, pause it and then start working on it and restart the video once you're ready to check. So it says starts from rest, so that'd be another 0. Has an acceleration of 3 meters per second squared. We don't know how much time it'll take to travel 101 meters. So this time we have acceleration. We don't have a final velocity, so we're going to want to use the 1/2 at squared equation. And for some of you, this is just second nature, but it's always a good idea to make sure that you're really considering and thinking this stuff through. So in this case, we're solving for t. The v0t disappears. The 1/2 times 3 would be 1.5. And this is where some people would make little mistakes of trying to subtract the 105, but we want to divide. I'm sorry, the 1.5 from the 101. Mixing up numbers. So those will cancel out, and we'll end up with t squared is equal to whatever 101 over 1.5 is. 67.3. And we're not done because we don't know what t is, not what t squared is. So then we got to square root it. So square root 67.3. And get about 8.2. Alright, not so bad there. So we just went through 4 accelerated motion problems. Let's take a look at some free fall questions next. For all of these, the acceleration is going to be that special value on Earth that we have of -10. And for these problems, I think we're just going to take a look at the setup. And I'm going to pause the video and just reveal what the solution is, and then do a quick description of what's happening, because doing the walkthrough does take quite a bit of time. I know it's helpful for some people to see that, but it's a lot of minutes on the YouTube there. So for this problem, like I said, because it's free fall, it's going to use the acceleration of -10 meters per second squared. All of them are. But it says balls dropped and observed to be moving at -50.9. So the velocity after it's dropped. Drop means it has to be starting from 0. Sometime later, it's moving at 50.9 meters per second, negative. That means downward. And we want to know how long it's been falling. So you should take a attempt at that, see what you get, and through the magic of editing, the answer will appear in, I don't know, about 3, 2, 1. Voila. So we should get 5.09 as the time. So we put in the final velocity, initial velocity 0, a is negative 10. Remembering, we don't add the negative 10 to the other side, we divide by it because it's multiplied to the t. So that's why I recommend putting the parentheses. And if we divide that, the negatives cancel out. 50.9 divided by 10 would be 5.09. Okay, next problem. It says if you throw a ball upward at 16 meters per second, what will be the size of its velocity after 0.5? So sometimes people get mixed up on this. They think that's the final velocity, but it's a velocity it has as it enters the air and becomes in free fall. So we're saying that's the velocity, and we want to know what's happening after 0.5 seconds. So the 16 is our initial, and it's positive because it's going upward. It's going upward against gravity. So negative 10 meters per second squared is our acceleration. We got a time of 0.5, and we want to know what the velocity is going to be. All right, so take a look at setting that up and getting an equation, and we'll take a look at the answer in about 3 seconds. 2, 1. And I get 11. So in this case, we have the initial velocity 16, acceleration negative 10 times 0.5. Again, you do not combine those two first. Parentheses, things are multiplied. So we have 16 minus 5, which would give us 11. So it's still going upward, just going 11 meters per second now. Okay, number 6. Calculators drop from a tall building. What amount of vertical displacement will it have in 3.38 seconds? I think I'd like to have you try to do this setup, including the variables for this one and everything, and then we'll reveal the answer to you in about 3, 2, 1. All right, so we got a whole bunch of work there. Drop, so the initial velocity 0, amount of vertical displacement, that's our delta x, or we could put delta y, with it'll fall in 3.38 seconds. Acceleration negative 10 again, because we got the a, we're going to use this equation. V0t disappears because V0 is 0. And you can put all this in your calculator at once because there's no unknowns there. I went ahead and wrote it out as 2 steps, but you should get an answer of negative 57.122. So that's how many meters it's fallen down. Negative sign means the measurement is downward. In this particular quiz question, you would just drop the negative because I want the amount. But on an exam, that'd be the best answer to have. Okay, let's take a look at second to last problem. And again, set this one up on your own, pause the video, and we'll see what the answer looks like in a couple of seconds here. Okie dokie. So we got a crate is 126 meters above ground, falls, which means it drops. And if it's going downward, that means the 126 displacement it's going to have during the time of the problem is negative. It's got a negative displacement. How long will the crate take to reach the ground? So question mark is the t, the acceleration is negative 10. We got an accelerated motion problem with displacement. We got to use this formula right here. Plug in the numbers, the V0t cancels out because 0 times anything, regardless of what the time is going to be 0. 1/2 times negative 10, I can do that math to get negative 5. And at this point, I've got the negative 126, and then I've got negative 5 times t squared. I divide the negative 5 away from the t squared. Left with t squared equals 25.2, and now I can square root it. And you can see my math on the calculator over here as well. All right, last problem. This one's the doozy. Probably work this one out live, just because this is a problem that people had trouble with when taking the quiz. It says a toy rocket is launched upward at an unknown velocity. Ooh. So it's launched upward, unknown velocity. After 2.3 seconds, I'm going to live write this in, it has a displacement of 67 meters from the ground. So positive 67. And we want to know the size of the initial velocity. So V0 is our question mark. And we know the acceleration is negative 10. So we don't know the final velocity. We know the acceleration. we got displacement. We're going to have to use that 1/2 AT squared equation again. And if I set it up, I can put 67 in. V0 is my unknown. I know the time's 2.3 seconds. Make that a 3. Oopsie. Let's see, -10 and 2.3 squared. So I can take care of all the, well, there's only a little bit of math I can do to start with. I can do 1/2 times -10 multiplied by 2.3 squared. There's a decimal there. And I get -26.45. So at this point, again, sometimes people will say like, oh, I'll just get that 2.3 and then this, and well, you can't. The 2.3 is multiplied to the V0. Can't do anything with it until you get rid of all the addition subtraction stuff. So I'm going to add the 26 to both sides. So it disappears on the right-hand side. If I add that to 67, what do I get? I get 40.55 equals V0 times 2.3. Now I can divide both sides by 2.3 because the 2.3 is multiplied to the V0. And I'll click divide by 2.3 and I get myself an answer of 17.6. The original velocity, 17.63 meters per second. So that was a challenging problem when we had it originally on the quiz. People had struggled with a little bit just because they're making math mistakes. But I'll remind you, on an exam, you get 1 point for having all your variables identified correctly. You get 1 point for selecting the correct equation, and then you get a point or two for maybe substituting the numbers incorrectly and then getting the right answer. Don't give you points for all the math. So you can get 2/3 to 3/4 of the point before you make any math mistakes. But don't make math mistakes. Practice. Come and get some help if you need some help. Otherwise, best of luck. I'll see you later.